This is the AWS Developers Podcast. In this week's episode, we're talking about governance of your AWS account with Adobe. Good morning, it's Friday morning. Every Friday morning in all good podcast application, you can find a new episode of the AWS Developers Podcast. We are recording the episodes that you're listening previous week, this week, and next week from the London Summit. We are at the Excel Center east of London. We are at the end of the month of April, even if you're listening to this episode a bit later. And in today's episode, I have the pleasure to have my partner in crime, Tiffany.
Hi, everyone.
Thank you for being here. And Johannes Gehrs, your site reliability engineers at Adobe, the software company. I have a naive question to start. Adobe is much more than Photoshop, isn't it?
Yeah, it is. You can say that Adobe consists of two big parts. One is called digital media, and that's what people usually associate with Adobe. So it's all the creative suite products such as Photoshop. There's also a part that does marketing and
content management,
e-commerce,
analytics,
enterprise software, broadly speaking.
So you have a talk, Johannes, at this conference. You have a breakout session later this afternoon to talk about governance and the story of Adobe. I think the title of your talk is "How to Not Clutter Your AWS Accounts." How did this cloud story start for Adobe many years ago?
Yeah, so Adobe was really an early adopter of AWS, I would say, and it was a very organic story of cloud adoption. So Adobe, let's say individual teams within Adobe just decided that AWS was a good fit for what they wanted to build, for what they wanted to achieve, and they just signed up. And that was broadly happening in the early 2010s.
Wow.
And they often just used essentially company credit cards to sign up individual teams for AWS. And that's the story of how AWS grew within Adobe, and now it's a big pillar of how we operate our services.
And so at some point someone realized, we have many different AWS accounts in different departments, just paid by credit cards. Maybe we should put a bit of order there. So what was the plan? What was the original idea to put structure in the chaos?
I think that's also a journey that AWS had as a whole. So if you think about, for example, AWS organizations, which is now sort of a important pillar of how essentially everyone manages their multi-account setups. What would you guess when it was introduced by AWS?
Organization, very late, too late probably for large enterprise customer. I would say like 10 years ago, a bit less.
2017. So that's a pretty good guess.
So 9 years ago.
So many of the things we now take for granted, they have not been around forever, but they are available now. And I think big organizations such as Adobe now have a fairly complex setup of governance and control structures and automated scanning and so on.
Yeah, because like every large AWS customer, large enterprise, you have hundreds, maybe thousands of different accounts. So the central IT must also put in place guidelines to ensure that every business unit is following the same set of rules. I'm thinking in terms of governance, about security, for example.
Exactly.
So in your talk this afternoon, you're going to go through three big pillars. One of them is the governance. Another one is an internal developer platform that Adobe put in place, and then infrastructure as code. Let's start with the first one, governance. What are the key foundation principles that Adobe as an organization put in place to manage the AWS accounts and the usage of cloud resources?
We use AWS organizations with a lot of sort of custom extensions that I'm not going to go into in too much detail. But a big part of what we also use there is SCPs.
So SCPs,
it's service control policies. So that's a form of IAM policy that AWS provides, which you can apply not just to one AWS account, but to your whole organization or to parts of your organization. And it essentially limits the things that principals, so that's users or roles, can do in your organization.
Yeah, that's a very good definition. It helps to set the boundaries of what is possible for all AWS accounts that belong in a part of the organization.
Exactly.
So that's the way decentralized IT can say, okay, you can use this service, but you cannot use that one.
Yeah, if you want, I can go through a few examples of
exactly.
the things we do with SCPs. So one thing is we just limit regions because we have these like microservices. So usually the microservices, they also need to communicate with one another. So you don't want them to be like spread over too many regions because it would make communication between microservices somewhat inefficient. So we don't use all AWS regions. We only use a subset, and we just disallow all the regions that we do not use. Another thing we limit is services. A good example I always use is AWS Ground Station. I'm sure it's a fantastic service if you do want to interact with satellites. But if you don't, then it's pretty safe to turn it off. And actually what we do, we have an allow list of services because AWS is notorious for releasing new services. And we kind of want to review them before we introduce them into our, let's say, custom set of services that we use.
Oh, I never thought of that. That's funny. Yeah,
the satellite or the new services.
The fact that we release so many services, and so they're not taken into account into your policies before they've been created. It's just okay. That's cool.
Yeah.
Which team at Adobe is in charge of that? You have a central team defining these policies?
I'm not part of that team, just to be clear. Yeah? I'm not directly working on that. That team is called Cloud Governance.
Okay. How do you ensure that these policies are correctly propagated to all the accounts? Are you using Control Tower or something like that? When a new account is created, how is it configured?
So Control Tower would be probably a great way to set this up if you start on a green field with a new startup. If in an organization like Adobe, where things have evolved over a really long time, I would say, let's say that's not the way it evolved. But
Control Tower was not even existing when you start to use AWS, so you had to build something else.
In general, I would say, these big corporations, they always have a very specific evolution, and you shouldn't listen too closely to what exactly they did because it may not apply to your situation. But one thing you can always have is that you can always have different OUs within your organization, and you should definitely review SCPs, and you should apply them only to parts of the organization. Those basically to test the SCPs, because SCPs have an extreme impact on what people can do in your AWS organization, and it can essentially shut everything down with one incorrect policy. So it's really important to review and test.
How do you test policies? Like, to be honest, I hate working on this, like authorizations and permissions. Like I always, I find it very complicated. How do you actually do policy testing?
Maybe I think that's something where AWS could maybe do more, but what you can definitely do is you can essentially copy the existing SCP, and you can modify it, and then you apply it only to, let's say, the non-production accounts in your organization, because usually you have AWS accounts that are used for production and AWS accounts that are used for non-production. So you would essentially apply the new modified policy only to the non-production accounts, or even to a subset of those accounts. It's a fairly manual process. But then on the other hand, the SCP also gives you a sort of lot of bang for your buck, because you just set it once and then you got rid of that problem kind of forever.
Yeah, or you create a problem for
yes.
So when
hopefully
you're
not
testing,
forever.
And back to Tiffany's question, you need to ensure that a new policy will not break any of the application, and have super strict monitoring in all application to verify that everything is still working.
But that's complicated
correctly.
to know.
That's probably the
Yeah, it's challenging.
Yeah.
There is something else than SCP. It's also resource control policy that has been introduced recently by AWS. So it's the same idea, but applied to a resource or a set of resource like an S3 bucket. Is it something you're looking at or using already?
So I'm not sure. I don't think it's something we already use, but it's a very interesting new addition by AWS, because one sort of gap in SCPs was that you can also have policies that apply to resources. The sort of most famous resource-oriented policy is the S3 bucket policy. So just to give you one example, with an S3 bucket policy, you can share the objects in your S3 bucket with other accounts, other AWS accounts, and they don't necessarily need to be in your organization. And that can be a problem because sometimes you have sensitive data and you want to have a centralized way to avoid it being shared outside of your organization. This is what AWS in their documentation, they call this data perimeter. And so with RCPs, it's fairly easy to set this up now. You can essentially express something like nobody is allowed to share objects from S3 buckets with accounts outside of the organization.
So that would help. That would simplify the management at scale across thousands of buckets and thousands of accounts.
It closes some gaps in what you could previously do.
Are you also implementing reactive testing, like script that validates that resources are deployed in a specific way, like scanning EC2 instance for specific tags or things like that?
Yeah, so the way I would think about this is everything you can do with declarative policies, like SCPs or RCPs, or similar things that AWS offers, that's great, because if you can set it declaratively, you don't need to scan for it. You can just set it and rely on AWS. But all the things you cannot set this way, you need to sort of automatically scan for with imperative code, essentially, batch jobs that scan for it and rectify things and alert people. So that's sort of the second part of the first pillar.
The first pillar is governance. So
the governance and automated scanning. So all the things we cannot do declaratively, we would have at Adobe. We have a lot of custom code that scans for things, and we scan for a lot of different things. I can't even enumerate them all, I think, without violating our time budget. Maybe one thing I can mention is S3 intelligent tiering. So that's something that AWS introduced. And S3 intelligent tiering chooses a good price, performance ratio, storage class in S3 for you at a very reasonable cost. So let's say it almost always makes sense to just transition objects after a while to intelligent tiering. So one thing we do is we automatically set a lifecycle policy that transitions S3 objects to intelligent tiering if there's nothing else set, and some more conditions that I'm not going to get into. But that's something I think that makes a lot of sense that people should consider doing.
And your script are verifying if the setting is there, or it's changed the configuration proactively if it is not there.
That's true.
Okay, so it's not just detecting and reporting an error, or
it's automatically rectifying misconfigurations that for which we are reasonably sure that they are, safe to rectify.
So that was the first pillar about centralizing the governance of the account through AWS organization, SCP, and automated scanning. The second pillar, I'm a bit more curious about that one. It's a platform that you created, which is called the Internal Developer Platform, IDP. What is it about?
Yeah, I mean, IDPs, I would say, are a big trend right now in the how do you say, DevOps landscape, maybe?
SRE.
SRE landscape, yeah. And usually it's built on Kubernetes. We actually at Adobe, before I joined Adobe, we started building an internal developer platform on Mesos. So that was that's the similar orchestration system to Kubernetes. But
was it from Apache, if I remember well?
Yeah, it was an Apache project.
It's an orchestrator of containers before Kubernetes.
Yeah, exactly. So it wasn't clear from the beginning that Kubernetes would rule the world.
No.
So, but now it's based on Kubernetes, but maybe let me first get into the why, right? Because that's what you asked. So it's just that we want to run services in a pretty uniform way. We want all services to look somewhat the same. And to realize that what we do is we have this Kubernetes platform where you always deploy in the same way. You always have sort of your CI pipeline set up in the same way. You always have monitoring set up in the same way. And certain security and compliance standards are enforced automatically. So this makes it just a lot easier to understand how services are operated, and it makes it easier also for people to switch teams, work on maybe on a different service, right? Because everything is set up in a similar way.
So this means that as a developer, I cannot choose my own technology to deploy code on the AWS cloud. I have to go through the platform that is standardized at company level.
There's some nuance, but essentially, yes.
So does it mean you never get to really see the AWS console? That's an abstraction on top of it?
Yes.
Oh.
That's true for sort of the compute aspect of it, but that's not the whole picture, because we always have, or we usually also have, let's say, stateful cloud components such as S3 buckets, DynamoDB, RDS, caches, and all of those things are not part of the IDP,
Oh.
and usually they're a big part of the application, right?
Yes.
So all of this is still in the public cloud, and developers interact with the normal AWS APIs.
Okay.
So what is the perimeter of that IDP? Is it just like a deployment platform for containers, or is it more strict with also, I don't know, GUI frameworks, logging framework, security boundaries?
Yeah, I would say it's somewhere in between. But it has to strike a balance between flexibility
Exactly.
and uniformity.
Mhm.
And I think, that's definitely a challenge, but it's something that Adobe has done now for more than 5 years, and I think we are getting better and better at it.
And again, what team is in charge of that platform?
It's a centralized platform team.
Okay.
Again, that's not a team I'm in.
Yeah.
So I cannot really speak from sort of direct experience when it comes to developing this platform. But it's a centralized team, and it's a substantial investment. I mean, I would always say, if somebody is thinking about doing this, an IDP is a big investment, because you have to provide a lot of APIs, you have to wrap a lot of cloud APIs, and it's not. I think it's not the right fit for every organization.
What is the boundary between application and that type of framework? I'm thinking about something like user authentication. Is it part of the IDP that all the developers have to use your company-wide API to authenticate an internal user, or is it the responsibility of each application to define a way to authenticate user?
Yeah, authentication is part of a centralized platform. I think it's not strictly speaking part of the IDP right now, but that's more pretty contingent. But there is
a central service.
There is a
for
central way to
authentication.
do this. Yes, and I think that's one of the domains where it makes a ton of sense.
Yeah.
I mean, you don't want every team to reinvent
reinvent.
authentication, authorization, and so on.
Same for the CI/CD. I guess the pipelines, it's also part of the IDP.
Yes. And that's, I think, one of those aspects where you do need some flexibility, because there's quite some innovation in how folks roll out applications. And I mean, AWS has a lot of great articles about that, and I think has done a ton of innovation in that space. So yeah, I would say that's one area where it's important to strike a balance between innovation and uniformity.
Yeah, that balance is probably the hard thing. What if a team wants to use, I don't know, serverless Lambda, for example? You said it's Kubernetes. So I guess there is a negotiation for these use cases.
Yeah, you would have to essentially have a good reason.
Yeah, come with them.
Yeah,
Show me why. Explain me why.
exactly.
How do you implement that IDP? Is it a set of, I mean, how do you enforce the usage of the IDP? Is it a set of CloudFormation template or CDK constructs that the team building applications have to use or reuse so that they fit into the framework?
So right now it's based on Kubernetes. It uses Helm, and that's the primary way that developers interact with it. Also, we have a UI for it. It's based on the Backstage developer portal, which is pretty popular these days. And the way it usually works is that if you do something in the UI, we try not to make it have a direct impact on your application, but instead create a PR, so that we always stay in this code first paradigm where we do things in Git rather than just clicking things in the cloud.
Either the AWS console or the Backstage developer portal.
Exactly. So I think that's a pretty cool innovation. Instead of falling into this sort of click ops trap, you can create PRs from UI actions.
I didn't know that. I have to learn more about that, and I will put the link to the Backstage portal that you were mentioning in the podcast application. So if you scroll down in your podcast application, you will find a link to that. But yes, the message is do infrastructure as code and not infrastructure as clicks.
Yeah.
With a console, the AWS console or any other console. So first pillar was governance. Second pillar was the internal developer platform. Third pillar is, and it's a good transition with what we just said, is infrastructure as code.
Yeah, exactly.
And standardizing everything on infrastructure as code.
Right. So the third pillar is kind of all the rest. Everything that is not covered by either centralized scanning, centralized governance, or our IDP is not done sort of super centrally at Adobe. And that's also what I work on in my corner of the organization. And a big part of this is infrastructure as code. And we have a fairly large setup in terms of regions and tiers and the number of resources we deploy. So I'm sharing some in my talk. I'm sharing some lessons on what we've learned from building this.
Let's go into that. What did you learn?
Sure. Yeah. So I think the first and maybe even most important thing is that because of this reason that I mentioned, that infrastructure as code is not the only or primary way to interact with the cloud. And people have often used the public cloud for a long time. They're kind of used to ClickOps or using the CLI. And it can be a cultural challenge to make people use infrastructure as code instead, because initially it's slower and it's a little bit more work.
And yeah, there is a learning curve as well. You need to learn how to write the code.
It's reasonably complex. So what do we do about this? So
what is the incentive that you give to developers to use IAC?
The first thing we try to do is we make it super easy for our developers to use this this product, essentially. So we have like a mono repo with all our infrastructure as code. So in our case, it's Terraform. And you don't have to set up anything. You can just commit your code. It has the right credentials. It has the pipeline that deploys it. We set all of this up for folks, and they just have to write down what they want, and then they get it.
Interesting. So you have an entire repo just for all of your infrastructure as code.
Yeah, not for all of Adobe, just to be clear. That's I'm working in a part of Adobe that's called ACPC, which is it stands for Adobe Content Platform and Collaboration. It's an underlying platform which the products such as Photoshop, for example, use to enable collaboration and uploading your files.
Nice.
Similar to maybe what you would get from iCloud and Apple.
Yeah. Okay.
Yeah, but we have a repo just with infrastructure as code with its own pipeline. So, I mean, that's one way to do it. You can also have this for every service, but we decided to have this centralized repository where all the tooling is set up. So we try to make it super easy for folks to use this. We also made it so that you can execute these workflows locally, and so you can get really quick feedback on whether there are any problems.
Yeah, so they don't need to wait for a deployment to fail and read the error message and retry and change. And at the same time, all the best practices are included into the default Terraform and the scripts that you provide, or the majority of the default.
Linting and automated testing and so on. And the other thing is also we try to make it reasonably safe to use infrastructure as code, because infrastructure as code can also be a little bit scary. If you commit something, it may bring down production. It may have an unintended consequence that you didn't expect.
Oops, I deleted the database.
Exactly. Yeah. That would be like the worst case, right? But fortunately, these tools such as Terraform and CloudFormation, they are able to preview what will happen.
They have safeguards. Yeah.
Yeah. So exactly. So Terraform has plans, and CloudFormation has change sets. And what we do is the pipeline commits back these plans in our case to the repository, so they become part of the PR review. And then when you review the PR and you click merge, then we replan everything and we check that what is now the result of the planning process is exactly the same as what was reviewed in the PR. And only if that's the case, we'll apply. So I think this is a good way to make it more comfortable for folks to actually use infrastructure as code.
How do you manage the drift that might happen if someone is not following infrastructure as code? And I do that quick change in the console because I can. Maybe the solution is to not authorize that at all. But at some point, you might have a difference between the code and the reality.
Yeah, I think if you have the expectation that you can get rid of drift sort of forever and then you never need to take care of it again, it's unfortunately very hard, because even if everybody is behaving perfectly fine, drift can occur. Just to give you one slightly counterintuitive example, maybe if you have an EC2 instance, which uses a specific AMI, and you're not pinning the AMI to a very specific version, but you just say something like use
the latest
AWS Linux some version, major version, you will get drift after a while because a new AMI version gets released. And when you replan, the infrastructure as code tooling will notice that actually that's no longer the latest version. And this shows up as drift as well. So drift is a fact of life, essentially, if you have a big setup. And what we do, we just have various ways to keep it at bay. So we replan every environment every night. And then we create PRs and we assign them to the responsible team. And we also create Jira issues. So folks really sort of get pushed to resolve this. And with this, we are able to keep it pretty minimal.
That's interesting. Does it mean that whenever you have a new developer coming into your team, they have like an onboarding of a certain amount of days to just understand how you guys process the code, how you guys work? Like, because this is a certain organization, right? Like, people that come into your team need to know how you work. Like,
Yeah.
does it take a certain amount of time to understand all of those processes?
I think so. I mean, and maybe that's a little bit of a downside of the way we build things, because it's fairly opinionated and sort of uses specific approaches. It's something you have a little bit of a learning curve.
Yeah.
Essentially, we just try to write a good README, and we are approachable to our developers, and we can also pair with them. I mean, if somebody's new, I really like to do pair programming.
So Adobe starts its cloud journey like 15 years ago, something like that. You said in the early 2010, if I remember well, at the beginning of this episode. It took a while, obviously, to create the governance role, the IDP, and to change the culture of the organization to go through infrastructure as code. But now that you are there, what are the evolution you see for the future? How do you see tomorrow and after?
Yeah, right now our developers, in some way, they need to live in two worlds. One world is the internal developer platform, and the other world is the public cloud infrastructure as code. And we want to bring these two worlds a little bit closer together. So AWS has initiated a new open source project called CROW. It stands for Kubernetes Resource Operator, I think. And this essentially allows you to create a curated set of public cloud resources that you can deploy using Kubernetes resource definitions.
So, for example, create an RDS database based on a Kubernetes resource definition.
So
did I understand correctly?
It's somewhat similar to what you can do with CDK, but it uses sort of Kubernetes as a lingua franca of interacting with the cloud. And this, in the longer term, this will allow us, I think, to get away, at least to some degree, from this approach where we have a monorepo for cloud infrastructure stuff, and instead we can have sort of co-located cloud infrastructure with the individual services, because you already have a repository for the service where you have all the Kubernetes manifests and so on, and we can sort of co-locate the curated set of public cloud resources, sort of encoded best practices with the service deployment definitions. And I think in the long run, this will allow us to bring these worlds closer together and to maybe reduce a little bit the mental load on developers.
So it's more Kubernetes, a bit less cloud-specific API or Terraform, for example. Does it bring a touch of portability as well? Like you can use the same or Kubernetes service definition to create resource on another cloud provider as well? Does it decouple a bit the infrastructure from AWS?
To some degree, yes, but I would really caution people to expect too much from this, because if you build an application, you're really dependent on the exact details of how things work. For example, if you use SQS, like it has like specific semantics for when it has really acknowledged the message and so on. And you usually at some point, in my experience at least, you will need to rely on these specific properties of the system. And sometimes folks have this idea that, there's a queue system from some competitor and a queue system from AWS, and it's basically the same.
It's a queue.
It's only basically the same. And
things like the visibility timeout, for example, is very specific to SQS.
And at some point, you will need to look into every single detail of the API and how everything works.
And the developer has to understand the semantic of the API as well before starting to build that. Governance of AWS account at large scale at Adobe, centralized governance, internal developer platform, and infrastructure as code. Johannes Gehrs, you are a site reliability engineer, SRE at Adobe. You have a breakout session at the AWS London Summit a bit later this afternoon. So thank you for stopping at the podcast booth, podcast studio, and to share your content with the listeners of the podcast. Good luck for your breakout session. Thank you for having listened to this episode until the end. With a bit of background noise, we are recording from the AWS Summit in London. See you next week for another episode recorded from here, from the Summit in London. But now, go build.